Hello everyone, and this marks the last bit of our mixtures, as I said before. And I had defined mixtures. Types of mixtures were three: solid mixtures, solid liquid mixtures, and liquid mixtures. So we had handled this. We had handled that, and now the key thing that I want us to handle is under liquid mixtures. We were supposed to dive into miscible liquid mixtures. These are the things that I want us to know. And this is how we are going to handle it. In separating miscible liquid mixtures, remember they are miscible. And to some extent, they can even form homogeneous mixture, meaning a uniform mixture, like forming a uniform mixture. So when such happens, separating such mixtures sometimes tend to be tricky for students. And as a chemist, to come up with a technique that can help you separate them sometimes becomes ambiguous. So to separate them, we use a technique that is called fractional distillation. Fractional distillation. This is fractional distillation. And fractional distillation is an improvement of simple distillation. It is an improvement of simple distillation. It is an improvement of simple distillation. And in this chapter or in this video, I'm going to dive deep into fractional distillation using a sketch and explaining every bit of it. Now, if I'm going to do that, this is how we are going to start. Let me start with the drawing. And we are going to analyze the drawing and know some of the important parts that we really need to be knowing in those drawings. Now, here, I'm going to start with my flask. The way I started in the simple distillation. I'm going to start with the flask like that. And this flask must have two systems. On one part, it must have a thermometer. Just trying to sketch. Sorry. On one part, it must have a thermometer. Then, on the other part, it's going to have a delivery tube. And this delivery tube is connected to something like this. In fact, sorry, I've drawn it badly. This thermometer is not supposed to be there. I'm supposed to have one full system like that. Then it is supposed to be connected that way. to another system. Then this is where now we are going to have our thermometer. So that's our thermometer. Then, so inside here, we are going to have some solid substances, and this system, I'm just going to do a sketch. Supposed to proceed all the way down like that. Then I'm going to have this, meaning I'm supposed to be joining it with supposed to have a condenser. Sorry, I'm now sketch it well. I'm artistically challenged in drawings, so you'll bear with me. Yeah, that's a little bit better, but let me wrap this end so that it can be curvy. Sorry, it's worse now. Yeah, that's fair. Now I'm supposed to have my collecting jar. Then this is where I'm supposed to have my mixture. And remember, it is homogeneous mixture, and I'm going to choose one of the mixtures. Then we put the wire gauge. Then on top of it, we have our tripod stand. Then heat. Now, so in labeling, I need to label. So this is my thermometer. Or let me use a different color. To use a different color. Green is better. So I'm going to have heat down here. Then mixture, which is miscible. Miscible mixture. Then wire gauge. Then this is going to be my thermometer. Then this thing here is called fractionating column. Fractionating column. Then inside it, around bottom things, solid like, we call them glass beads. Glass beads. Then this one is the condenser. Warm water out. Then here we have cold water in. Then we have collecting. We have collecting base in there. So the key things that you need to be knowing are, whenever we have a system like that, now what we are supposed to be knowing is that This system is supposed to be separating certain mixtures, and these mixtures must be separated in a unique way. So after setting up your system like this, you're supposed to know the role of the thermometer. What is the thermometer do? And if you compare this structure that we have and the structure that we had in the simple distillation, you see a very big difference. But it's not that big. To me, it's just a small difference, because the only thing that is new that was not there in the simple distillation is the fractionating column. So as a student, you're supposed to know what is the role of the fractionating column. What is the thermometer doing here? Those are the key things that I want you to be knowing. So after knowing those key things, so it will be easy for you to do an analysis and know. And remember, we use fractional distillation to separate mixtures that consist of components that have different boiling points. I'm going to say that again. They have different boiling points. Meaning if there are two or more substances, but the key thing about those substances, their property of boiling point still differs, even in the mixture state that they are in. So I'm coming back to my system. Then in that given system, I have to know that I have my collecting basin here. Then this is water. I said it supposed to run here. So it is supposed to cool the vapor that is coming out from our system here, that is being heated inside here. So it is supposed to be cooled. Now let me dig deep now into key things that you're supposed to know as a student about this structure. The key thing, the only difference between fractional distillation and simple distillation is the fractionating column. Fractionating column. And most students always have problem in this. The first thing is the function of the fractionating column is to create a system that can condense vapor. Create a system that can condense vapor. So imagine a situation whereby I was having ethanol. Let me take for example, before I dig deep there, let me rub this and say, for example, I wanted my mixture was ethanol and water. So when I have this mixture, these substances have close but different boiling points. Ethanol boils at 78.8 degrees Celsius when pure, but water boils at 100 degrees when pure. So when I subject these two to this system, I want to use these two examples to bring out the function of the fractionating column. Now, when we start heating, most of the time when you are heating anything on a cooker, for example, I'm having water, then you start heating it. When at home, you'll realize that before 100 degrees Celsius of water is reached for it to boil, some vapor will always come out while you are heating. So this vapor are the things that are catered for here with the fractionating column here. Sorry. So imagine a situation whereby when I'm heating these two mixtures in this system, so I can say I can have water and ethanol in my system. When I start heating, some water might evaporate before the boiling point of water is reached, because I expect the first substance to be collected here to be ethanol. meaning I'll continue heating. As the temperature of the system rises, the thermometer reading will increase. But immediately it hits 78 degrees Celsius, I'm expecting some drops of ethanol to be collected because it is ethanol that will be leaving the system. So if it increases to 80 degrees Celsius, remember we are past the boiling point of ethanol, but we've not reached the boiling point of water. So meaning at that stage, between these, the temperature will remain constant until all the ethanol boils and evaporate. So if they all boil and evaporate, at the same time, remember sometimes some water might leave the system and rise up. So what happens when they rise up? Remember, water is supposed to boil at 100 degrees Celsius. So when they rise up, they find a cooler system. It's going to be cooler system. So what do? They condense back into liquid and it drops into the system. So what will happen is they'll condense back and drop back as droplets because we've not reached the boiling point of water. That's the main function of the fractionating column, is to condense back that given constituents of the mixture that have a higher boiling point, that might have boiled or might have escaped before the boiling point of that given substance is reached. So if I'm dealing with ethanol and water, while ethanol is boiling, some water might escape. So I'm expecting the fractionating column to provide a system or a condition that will make water to condense and flow back into the flask. So what is enabling the fractionating column to do that? The fractionating column has a glass beads. This increases surface area for condensation. Increases surface area for condensation. But it's only going to be increasing surface area for condensation of that given substance that has a higher boiling point. But immediately the temperature increases within the system and the temperature reading on the thermometer now hits 100 degrees. We expect water. So we are supposed to remove these at 90. We are supposed to be removing this because we expect all the ethanol to have boiled now. So the next distillate that we are supposed to be collecting is now going to be water after we've collected ethanol. So that's the key thing. So the major thing about fractional distillation is that it separates mixtures whose components have different but close boiling point. So that's the major function of, or the major use of fractional distillation as a separation technique to separate miscible liquid mixtures. So we can use it to separate different, even organic substances, the one we use in the oil refineries. You realize that whenever we are refining oil from crude oil, we have different substances. We can have petrol, paraffin mixed together. So crude oil is a mixture. Example of mixtures, we have crude oil. Crude oil is a mixture. So it contains paraffin, or the kerosene one. It contains petrol in it. It contains diesel in it. It contains We call it fuel oil. It also contains bitumen, the one we use in the tarmacking of roads. Sorry, that's not the right spelling. Call it bitumen. Bitumen. All these are found in crude oil. So crude oil is a mixture. So when it's subjected to fractional distillation, we get all these components. And what's the principle? Based on different but close boiling points. Boiling points. So that's what I had prepared for you as far as separation of miscible liquid mixtures are concerned. And it marks the end of our mixtures as a subtopic under principles of chemistry. Have a wonderful time.